So we were doing 9701 paper 41 May June 2023 paper. We did question number 2 last time. Okay, so we are going to start question number 3. Okay. Question number 3 says aqueous acidified iodate ions react with iodide ions, okay, as shown. The initial rate of this reaction is investigated. Table 3.1 shows the results obtained. Table 3.1 shows the results obtained. Okay. So they are saying what is meant by order of reaction. तो बेसिकली वो यहाँ पर ऑर्डर ऑफ रिएक्शन की डेफिनेशन पूछ रहा है आपसे. और order of reaction वैसे is the sum of the exponents of the rate equation, है ना, is the sum of the exponents which are present in the rate equation. तो अगर आप इसमें देखो तो rate equation में if you can see the powers, that is I can say 2 and 2. So almost second order with respect to H positive, and the same thing like second order with respect to like I minus. Okay, so the definition of the order of reaction is the power, it's the power to which the concentration, it's the power to which the concentration of a reactant is raised in the rate equation, like I mean to say कि ये जो power है आपकी इसका sum. Okay, so order of reaction with respect to IO3 minus, they are asking the order of reaction with respect to this IO3 minus. If you remember कि obviously आप इसका ऑर्डर ऑफ रिएक्शन जो है वो फाइंड आउट कर सकते हो. कैसे कि it's of 1 mark. Okay, so that the power is 1, so this is 1, the power is 2, so the overall order is 5. It's very easy. Use your answer to A part 2 to sketch lines in figure 3.1 to show the relationship between the initial rates and the concentrations of IO3 minus and I minus. If you remember, its order is the first order. So the first order graph is just like that. Okay, IO3 minus, it's a straight line, and the order is second. So ultimately you would be drawing the curve in this manner. Okay, this is the second order curve, right? Use data from table 3.1 to calculate the rate constant for this reaction. Like hopefully you will all know the curve of the first order and the second order. Okay, first order means that when the concentration is doubled, so the rate is doubled. When the concentration is doubled, so the rate is doubled. Like I mean to say, if this is 2, so this is 2, right? If this is 4, so this would be 4. If this is 6, so this would be 6. If this is 8, so this would be 8. I mean to say this. But if you can see that when the concentration is doubled, so the rate would increase by 4. So the rate would increase by 4 basically. So that's why you can see this curve. Right? So like let's suppose if the concentration is doubled, so the rate would be 4 times. And if this is 4, so that would be 16, right? So means that this is second order with respect to Hi minus. So that's why you can see the shape of the curve. Okay. Use the data from table 3.1 to calculate the rate constant of this reaction. So table 3.1 shows you are given the concentration of IO3 minus, you are given the concentration of H positive ion, you are given the concentration of I minus ion, you are given the rate. So you can find out the rate constant. You can find out the rate constant since this is the equation. Since this is your equation that is given to you, rate is equal to K into concentration of IO3 minus into H positive into I minus. I'm going to use this equation. Rate is equal to K IO3 minus H positive square I minus square. So rate is given, that is rate is given, that is 4.2 exponent minus 2. Okay, we have to find out concentration of IO3 minus is we are going to use this, okay, 0.04, 0.015, 0.025. So that would be 0.04 into 0.025 into 0.015 square and square. Okay, so we would be calculating K so the answer would be 2.25 exponent minus 2. The answer would be 2.25 exponent minus 2, right? Okay. Can you solve it? Can you confirm the value? Yes. जल्दी से.
Sir, I got 168.
168. 9999999. Impossible. Impossible. The answer should be 7.47 into 10 raised to the power 6, positive 6. This is the answer. So you can confirm.
Yes, sir, I did something wrong.
So then we are going to solve the units basically, right? So the units are K is equal to rate. Rate is mole per dm cube per second, divided by how many concentrations? In the denominator, we have 3 concentrations. So what's the total power? What's the total power? 5. 2, then 2, then 1. If you remember, 2, then 2, then 1. 2, then 2, and then power is 1. That's why I'm going to put 5 over there. Then after cancellation, it would be minus 4. 5 3s are 15. Then it would be plus 15 and minus 3. That would be plus ka 12 and then per second. That's the unit. That's the unit. Mole minus 4 dm plus ka 12 and per second. So if you can think that They are, oh my god, it's per minute. Okay. It's not per second, it's per minute. Okay, हो गया जी. So that's the unit. Use the data from table 3.1 to calculate the concentration of hydrogen ions in experiment 2. So this is unknown. We have to calculate this. We know the concentration of this. We know this. We know the rate. We know the rate constant. We know the rate constant. So we can solve this very easily. We can solve this very easily. So I'm going to use the same equation again. This is my subject square. That would be equal to rate upon K into this into this into this. अब आप रेट की वैल्यू देख लो. इसके लिए क्या है रेट? 7.09 exponent minus 2. K is the same answer that we have found in the part 4. Okay, so we can use that K. Okay, we can use that K, right? Concentration is 0.120 and 0.0125. 0.120 into 0.0125 0.0125 raised to the power 2 raised to the power 2. Okay, done. Okay, can you tell me an answer? Can you tell me an answer?
Sir, I got 5.06 multiplied by 10 raised to the power negative 4.
एक मिनट. 5.6.
5.06.
5.06 10 raised to the power minus 4. अच्छा, ये h प्लस का स्क्वायर है, ये देख लेना साहिल. स्क्वायर को लेने के लिए, स्क्वायर को खत्म करने के लिए आपको स्क्वायर रूट लेना पड़ेगा, ये भी ख्याल करना. So have you done like that?
Then it's 0.02.
ये देखो, in aqueous solution iron 3 ions react with iodide ions as shown. The initial rate of reaction is first order with respect to Fe3 plus. and second order with respect to I minus. The mechanism for this reaction has three steps. Each step involves only two ions reacting together. Suggest equations for the three steps of this mechanism. Identify the rate determining step. So they have given you the main equation and they are asking the possible mechanisms, right? So I can do first Fe3 plus is going to react with 1I minus, not 2I minus. I need to make this equation in three steps. So what it would be forming? What it would be forming? It would be forming FeI. 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 Okay. This is 3 plus. So ultimately overall charge would be 2 plus. Overall charge would be 2 plus because plus 3 and minus 1. So the overall charge is plus 2. Then this is not the part of your equation. Ultimately this is an intermediate. जो आपके इक्वेशन का पार्ट नहीं होता वो क्या होता है, इंटरमीडिएट होता है. पक्की बात है कि सेकंड इक्वेशन में ये होना चाहिए. सो FeI प्लस 2. ओके, आई नीड वन मोर I माइनस क्योंकि इस इक्वेशन में 2I माइनस है. आई नीड वन मोर I माइनस. सो व्हाट्स द प्रोडक्ट? सो व्हाट वुड बी द प्रोडक्ट? तो आप इसमें क्या कहोगे कि द प्रोडक्ट वुड बी, ये देखिएगा जरा, द प्रोडक्ट वुड बी so the product would be Fe2 plus, oh my god, so the product would be Fe2 plus again and I2 minus again. Okay, I2 minus, and then in the third step I can write again because I need one more Fe3 plus, so it would be reacting with, I have to cancel it out, so I'm going to write over there so that they can cancel each other. And I need one more Fe2 plus, so I'm going to write one Fe2 plus, and I need I2, so I'm going to write I2. When you are going to add these three equations, they would be canceling each other, so they are going to cancel each other, right? So you would be getting your same equation. That's it. So basically you have to form the three equations whose sum is this. It's up to you. Whatever you are going to form, it's up to you basically. And they have given you the hint. The initial rate of the reaction is first order with respect to Fe3 plus and second order with respect to I minus. Okay. So rate of reaction is equal to K into concentration of Fe3 plus into concentration of I minus. So first order with respect to Fe3 plus and second order with respect to I minus. So what's the equation which is the rate determining step? Rate determining step is the slowest step. Rate determining step is the slowest step, you know. So किसको मैं कहूँ कि यार ये मेरा slow step है? किसको मैं कहूँ कि ये मेरा slow step है? Slow step है. If you can see, okay, I'm going to write down the rate equation for third step. चलो पहले मैं पहले step की लिख लेता हूँ. So the rate equation for the first step would be this. Okay, it would be this. क्या ये इससे match कर रही है? No. So this is not a rate determining step. This is not the slowest step. No, wrong. अब मैं बना रहा हूँ step 2 की equation. So step 2 का rate equation बनेगा rate is equal to K into concentration of Fei plus 2 into concentration of I minus. Since Fei2 plus is depending upon these two, so I'm gonna replace this Fe2 plus ion with the I minus ion, and one Fe3 plus ion ultimately I'm going to make it simple. So I minus and I minus, it would give us I minus raised to the power 2. So this equation is going to match with your rate equation. So step number 2 is the slowest step, is the rate determining step. So I would say step number 2. I would say step number 2 is the slowest step because the reactants are involved in the rate equation. देखो ये सबसे बड़ी बात होती है कि वो involved भी है या नहीं है. Okay. State the hybridization of the carbon atoms and the carbon-carbon hydrogen bond angle in benzene. Explain how orbital overlap leads to the formation of sigma and pi bonds in benzene. So इसमें ultimately, if you remember, this is the benzene ring. This is the benzene ring. Each and every carbon is double bonded. And whenever the carbon is double bonded, so ultimately the bond angle would be 120 degrees. और उसकी hybridization क्या होगी? sp2 hybridization. Whenever you can see the double bond, so the hybridization would be sp2. Remember, sp2, always sp2, always sp2. दूसरा ये कि sigma bonds are formed by the head-to-head overlapping, and pi bonds are formed by the sideways overlapping of the p orbitals. Okay, so let's write this answer. Okay, in benzene, every carbon is double bonded. Every carbon is double bonded. Okay, or so the hybridization is sigma formed, sigma bond is formed by head-to-head overlapping of orbitals, and pi bond is formed by sideways overlapping of p orbitals. Okay. Compound Z can be synthesized from benzene in 3 steps by the route shown in figure 4.1. So what's the structure for X and Y? This is the simple benzene. Now you can see the things are attached over the benzene ring. Ultimately, you have to think, what's that? So I remember this is alkylation. This is what? Through alkylation, it's attached. It's through alkylation. Through alkylation is attached over there. Okay. I need to do alkylation. I need to do alkylation. Okay. I need to do alkylation, right? Like that. And then I need to do the nitration. Ultimately, this group is electron donating group. This group is electron donating group, and electron donating groups are 246 directors. तो वो आने वाले को कहाँ भेजेगा? यहाँ पर. तभी तो वो लगा हुआ है यहाँ पर. तभी तो वो लगा हुआ है यहाँ पर. अब आप ये सोच रहे होगे पहले मैं नाइट्रेशन करवा लेता. कैसे करवा लेता पहले नाइट्रेशन भाई? नाइट्रेशन करवाओगे तो NO2 लगेगा, NO2 लगेगा, NO2 लगेगा, और NO2 अगर लग गया तो NO2 तो इलेक्ट्रॉन विथड्रॉइंग ग्रुप होता है, वो तो आने वाले को 3 और 5 पे भेजेगा, है ना। तो ये तो 3 एंड 5 पे नहीं लगा हुआ, ये तो ऑपोजिट लगा हुआ है, तो दैट्स व्हाई यू हैव टू डू फर्स्ट एल्काइलेशन, दैट्स व्हाई यू हैव टू डू एल्काइलेशन and then you have to do nitration, okay. Draw the structure I have drawn, give the reagents and conditions for step 1, 2 and 3. देखो, for step 1 you are going to do alkylation. For alkylation, if you remember, we used to use catalyst that was AlCl3, or you can use AlBr3, or you can use AlBr3, okay. So कितने कार्बन मैंने ऐड किए हैं? 3 कार्बन मैंने ऐड किए हैं, 3 कार्बन मैंने ऐड किए हैं. 2 carbons are in the form of branch, and this is the main carbon in which the Cl is attached, and along with this is AlCl3. That's it, okay. Or I can say, okay, in step 2, concentrated nitric acid, concentrated sulfuric acid, you remember भाई, रिएजेंट्स और कंडीशन बड़े इंपॉर्टेंट है यार यहाँ पर. और NO2 को चेंज करेंगे NH2 में, मींस दिस इज रिडक्शन. आई एम गोइंग टू यूज रिड्यूसिंग एजेंट, दैट इज Sn plus HCl. टिन मेटल है और हाइड्रोक्लोरिक एसिड कॉन्सेंट्रेटेड होना चाहिए, तो ये रिडक्शन हो जाएगी और आपका NO2 NH2 बन जाएगा. दैट्स इट. गिव द सिस्टमैटिक नेम ऑफ W. इसको सिस्टमैटिक नेम देने के लिए आप देखोगे कि आपका जो NH2 है, that is the preference, that is the preference, that is the preference, okay, that is your preference basically. तो 1 2 3 4 5 6, so you know 3 दफा मिथाइल लगा हुआ है, 3 दफा मिथाइल लगा हुआ है, तो that would be 3, 4, 5 trimethyl phenylamine, trimethyl phenylamine. This is amine, okay. Number of peaks observed in W and Z. Okay, W and Z. W is this. Number of peaks in what? In NMR spectroscopy. NMR. Carbon 13 NMR. You have to see कि कितने तरह के कार्बन इसमें इन्वॉल्व हैं. It's called environment. It's called environment. You know, it's called environment. तो एक तो ये है, ये दोनों एक जैसे हैं, ये एक जैसे हैं, ये अलग है. तो कितने हो गए? 1 2 3, ये 4, फिर ये और ये 5, और फिर ये आपका 6. तो टोटल 6 इन्वायरमेंट्स हो गए W में. अब Z को चेक कर लेते हैं जरा. दिस इज द Z, दिस इज द Z. सो लेट्स चेक द Z. ओके, हाँ. दिस इज फर्स्ट, सेकेंड, थर्ड, फोर्थ, फिफ्थ, सिक्स्थ. 1 2 3 4 5 और ये 6. अगेन आई हैव 6 इन्वायरमेंट्स. तो इसके लिए NMR आपको पता होना चाहिए. जब हमने आपको इन्वायरमेंट लेने सिखाए थे, देखो ये और ये सेम कार्बन है, फिर ये और ये सेम कार्बन है, ये अलग है, ये डिफरेंट है, ये डिफरेंट है, ये दोनों सेम आ गए. तो जब सेम आते हैं तो उसको हम एज अ 1 काउंट करते हैं. तो टोटल अगर आप देखो यहाँ पर, तो 6 तरह के डिफरेंट कार्बन इन्वायरमेंट्स हैं. तो एक्चुअल में जब हम NMR पढ़ रहे होते हैं, तो जितने इन्वायरमेंट्स होते हैं ना, उतनी पीक्स आ रही होती हैं. जितने इन्वायरमेंट्स होते हैं उतनी पीक्स आ रही होती हैं. ये बड़ा सिंपल सा कॉन्सेप्ट है. तो इसलिए इन्वायरमेंट बड़ा इंपॉर्टेंट रोल प्ले करता है NMR में. सो यू मस्ट नो द इन्वायरमेंट्स, हाउ मेनी इन्वायरमेंट्स इन अ पर्टिकुलर कंपाउंड. तो उसमें हम यही देख रहे होते हैं कि भाई कितने 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 डिफरेंट इन्वायरमेंट्स हैं. हम नेबर से हेल्प ले रहे होते हैं, इसका नेबर क्या है, उसका नेबर क्या है. नेबर अगर सेम होता है तो हम कहते हैं वो इन्वायरमेंट सेम है, नेबर अगर डिफरेंट होता है तो हम कहते हैं कि वो इन्वायरमेंट डिफरेंट है। सो दैट्स थिंग। ओके, सो क्वेश्चन नंबर 4 जो है हमने यहाँ तक कर लिया है। ओके